Thank you, Chairman. I'm Satoru from Nagoya University, Japan. This is my presentation title. So the progress of global warming is a very serious environmental problem all over the world. So due to the progress of the global warming, many extreme weather events such as extremely hot days and heavy rains have occurred recently. So this figure shows that the number of hourly precipitation of 50 millimeters or more at 1300 observation sites in Japan. So generally, the number increases as the year advances. So heavy rain are expected to increase further in the future. So due to the global warming progresses further. So the final purpose of this study is to estimate the expected flooding areas under future climate conditions and to investigate the effective implementation of green infrastructures to mitigate the future flooding disasters. The target area in this study is the Nagoya metropolitan area. This metropolitan area is the third largest metropolitan area in Japan. So the target period, the 2030s and 2050s. So in order to perform future climate projections, we introduced a dynamical downscaling simulations from global scale to urban scale, based on the pseudo global warming method. So there are many physics models in the dynamical downscaling models. So it is very important to verify their performances in advance. So as an example, these figures that show the comparison of the performances several cloud microphysics models and turbulence models in predicting air temperature and precipitations. In that case, the combination of the Thompson model as the cloud microphysics model and the MYJ model, Mera Yamada model as the turbulence model is corresponded well to the observation data. The 10 years average the result corresponded to the observation data uh, among the compared to the other combinations. So these are the example of the climate projection result. The left figure shows the monthly average diurnal variations of air temperature at the height of 2 meters. So the air temperature becomes higher as the period advances, like this. So the left figure shows the monthly accumulated precipitation for the month of July. But however, so as see as far as we see this figure, the precipitation does not always increase as global warming progresses like this. However, it is considered that as the global warming progress, the water vapor, water evaporation from water bodies will increase, but and it will bring the larger amount of precipitation. But this result does not show such a trend. Therefore, so more detailed examination on this matter is required in the as future issues. So next, I explained how to estimate the flooding areas. So in this study, so we estimated the flooding area based on the relationship between the precipitation and the factor of contributing to flooding. Here, we introduced the 5 factors contributing to flooding, the elevation, topographic slope, land use, topographic category, and surface geology. So the left table shows the precipitation under the past flooding disasters in the target area, occurred in the target area. So these are the observation results. However, please note this is a part of observation data we obtained. So according to the table, the flooding disaster, flooding event occurred in the situation and locations shown in the light blue colored cells, these ones. So using these observation data, finally we derived the relationship between the precipitation and factors contributing to flooding. So as an example, this figure shows, the right figure shows the relationship between the precipitation and one of the factors, topographic slope. The one is this is an example. So this table summarizes the relationship between the hourly precipitation and the flooding conditions. This is a result. The left figure shows the expected flooding conditions, flooding areas. That is that black colored areas, these areas. In case of hourly precipitation of 90 millimeters. However, please note in this result assumes spatially uniform precipitations. So the right figure shows the comparison with the actual flooding areas during the past heavy rain occurred in the target area. So from this result, the area within the blue frames, this area, and this area, are locations where our precipitation about 90 millimeters occurred during the past heavy rain in the target area. So the black colored expected flooding area corresponds well to the actual flooding areas, like this. However, in the previous slide, we assumed the spatially uniform precipitations. But in fact, the precipitation has a horizontal distributions. So when we use the actual distribution of precipitation into the relationship between precipitation and the factor contributing flooding, so we can obtain the more realistic flooding areas. So in particular, when we use the future projection of precipitation in relationship between precipitation and the factors contributing flooding, so we can obtain the expected flooding areas under future climate conditions. These 5 figures are examples of the expected flooding areas and the 5 future precipitations. Among these cases, the cases within the in the middle of an upper road is the most serious flooding disaster situation. So finally, I introduce one of the implementation effect of green infrastructure against the severe future precipitation disaster. In the target area, there is a future goal in expanding gray infrastructures to prevent flooding damages caused by hourly precipitation of 63 millimeters or less. Therefore, we try to investigate implementation effect of green infrastructure for hourly precipitation of 63 millimeters or more. So in this study, so we introduced two green infrastructure technologies such as rain garden and infiltration trench. So this is the result. The left figure shows the number of locations where the green infrastructure technology can be introduced. These are the numbers. So this is the implementation. The left figure shows the implementation result. Blue colored area removed by introducing the green infrastructure technologies, rain gardens and infiltration trenches. So this is the last slide. So future challenges. In the next phase of this study, we conduct the detailed examination of the relationship between the implementation effect of green infrastructures and their cost performance. In addition, we will conduct more detailed projections of flooding damages by using runoff flood analysis model. Thank you very much for your attention.
Are there any questions?
If you have your green garden model there for collecting water when you have a lot of rain, what total volume, say, per square kilometre?
Volume, so I'm sorry, I forgot.
You have to retain water rather than
Yes.
having floods.
Yes.
So what volume?
Volumes
total
are
volume
very
you-
large volume. Very large volumes are
Yeah.
needed.
So-
But I'm sorry that completed area I forgot.
Yeah.
I'm sorry. Actually, this is my student research.
Oh, okay.
I'm sorry.
Okay.